Today we're going to look at sketching polynomials. Okay, so the key word here is sketching. We've done a lot of graphing, but this is we're not going to have specific points for some of the things that we are doing. So they're not exact graphs. Are you even listening to me? I didn't think so. At least you're honest. Okay, pay attention to me. All right, so this is going on page 35 when we're done. And we're going to start at the bottom. Okay. So in behavior, again, we're finally going to start talking about some middle behavior today, but in behavior. So you have two options when you have polynomials. It's either going to be an even degree polynomial or an odd degree polynomial. So you decide which it is, right? And then your leading coefficient's either going to be positive or negative. So if you have an even degree positive leading coefficient, then the end behavior is going to be just like the end behavior of a quadratic. It's going to be up, up. So it's going to look like this. So what this is saying is, as x approaches infinity, f of x approaches infinity. And then this should say, as x approaches negative infinity, and I forgot to fix it, then f of x approaches infinity. I'm a victim of cutting and pasting there. Okay. I know. What? So difficult. At least you didn't have to write it all out. So even degree negative leading coefficients, just like the quadratic was reflected in the x-axis, so it's going to be down, down. So anytime it's even, the end behavior, the two ends are the same. It's either up, up, or down, down. So as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches negative infinity. Okay. So then for odd degree, it has the end behavior of a cubic. So when we have a positive leading coefficient, cubic would look like this. So as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Odd degree, negative leading coefficient. It's like that cubic was reflected in the x-axis, so it's going to be up, down. So as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches infinity. Okay, so these are pieces of stuff we're going to have to figure out in order to be able to sketch these polynomials. All right. So if we go back up to the top, we'll talk through this list of stuff to do. So in order to graph it, I mean, we need to know a lot of the same things we needed to know when we were graphing things as well. We're going to find the x-intercepts or the zeros. We know how to do that. We're going to find the y-intercept. There's only one, so there's no s there. And it's just a constant when it's in general form. Most of what I give you is going to be factored, though, so we got to figure it out. Then we're going to notice if the polynomial has an even or odd degree. We look at the highest degree. Michael, you are still not listening to me. Okay, well, I'm sorry that you're hungry. Focus on this. All right, so we decide if it has an even or odd degree. We notice the sign of the leading coefficient, and that helps us determine the end behavior of the polynomial. So all that kind of goes together. If I have a positive leading coefficient, my two options are either up, up, if it is even, or what would the other one be? It would be down, up, if it's positive. This would be even, this would be odd, right? If it's negative, then it would be either down, down, or what? Up, down. Okay. Then we want to notice if there are factors with a degree higher than 1. So what that would look like is I might have x plus 2 squared or x minus 5 cubed. That would mean the factor has an exponent or a degree higher than 1. If that happens, then here are the two things that we know about it. If I have an even power, so this one right here, this is your even power. Even power of a factor gives a relative min or max on the x-axis. So that would mean whatever else could be going on in our function, but it would just come down, and basically that makes a bounce. Okay? But there's more going on in the function. That's just, kind of that part. If we have an odd power greater than 1, and this should say 1, I left off the e, but it has to be greater than 1, locates a point of inflection on the x-axis. So here's an odd-powered factor. We get a point of inflection. We should know what a point of inflection looks like, right? Something like that. And this we can call our wiggle. So we can either wiggle or bounce, or we pass straight through. Then we draw the continuous curve because there's no breaks in there. It's all continuous. Observing proper behavior at each 0, y-intercept, and end behavior. And you can check yourself. If you don't agree with yourself on the end behavior once you're done, something's wrong with your sketch. Okay? Or you had the wrong y-intercept or something's weird. Okay? Any questions at this point? Probably wouldn't even know what to ask at this point until we do one. So let's flip this over. All right, so here's our first one. Y equals, and it's already all factored for me. So things I have to figure out is the degree. So if I multiplied all that back together, what would the highest exponent be? X cubed. It would be 3. So this means that this is a cubic. But it's not like graphing the parent function because there's other stuff going on in there. All right. Our end behavior then, since it's positive leading coefficient and it has end behavior of a cubic, obviously, would be down, up. Then how many x-intercepts am I going to have? How do you find an x-intercept? Set y equal to 0. So if I set y equal to 0, I would actually have 3, right? Because this isn't like a parent function. Your graph isn't going to just look like a cubic. Okay, if so, we would do it with transformations and we could actually graph it. This is a different kind of cubic function that's got a lot more going on. So I would have 3, okay, and since it says x-intercepts, what form do I have to write it in? Ordered pairs. So my first ordered pair, I don't necessarily need to write these all out because I should be able to figure it out pretty easily. -1, 0, then 3, 0, then -4, 0. And should I put little union signs in between them? No, because they're not intervals. All right, and then I need to find the y-intercept. Y-intercept is when x is 0. So y equals, so if I just substitute 0 in for x for all of those, I'm going to multiply 1 times a -3 times 4. And I suggest you write it out, even when it's simple, because if not, you're going to make some sign errors. I mean, trust me, those are going to be what get you more than anything. So what's my y-intercept? -12. So I'm at 0, -12. All right, so now I'm going to graph this thing, right? I'm going to sketch this thing, sorry. And you're going to have to put the little hash marks on here because it just depends on how many x-intercepts you have. So we're going out to -4, so maybe we put 5 little hash marks on there. So 1, 2, 3, 4, 5, and just do your best to space them evenly. You don't have to get out a ruler or anything. Mine's probably a little off here, like these aren't the same, but I'm going to leave it. And then since I'm counting by ones on the x-axis, I don't have to label anything, but I also need my my y-intercept. So it's down here at -12. I'm definitely not making 12 little hash marks, and the scale is clearly different than the x-axis. All fine. Right? So then I'm going to put in my points. I've got x-intercepts at -1, 0, at 3, 0, and at -4, 0, and then I have a y-intercept at -12. I do not have any bounces or wiggles here. I know what my end behavior is. So my end behavior is what tells me how to start. What I don't know is my relative max and mins. So when I pass through the axis, I don't necessarily know how high to go up or how low to go because I don't know where those points are because that requires calculus that we don't know how to do yet. But what I do know is that the end behavior is down up. So if this is my first intercept, and you don't get to cross through the x-axis if you didn't make a point there. All right, so you don't get to come back through for just some weird reason. So I know I have to start down, comes up. I'm going to go down through there, down through my, oops. Sorry, I'm trying to do it off to the side and come down through here and then back up that way. So my end behavior I said was going to be down up, and that's what happens once I take care of all of my points. And here I want you to make a note that this point right here is not necessarily a minimum. Okay? Because we don't know where the minimums are. So I don't know that -12, it's like sometimes, and you'll probably notice yourself, and it's hard for me not to, that's why I really think that when you're going down there to hit the y-intercept or even up, a lot of times you'll draw it as your maximum or minimum, and that's fine because it might be. We just don't know. And so since we don't know exactly where this maximum is or this minimum is, maybe this thing really went way up high and then came back down, or maybe it just barely did it because we don't know those things. That's why this is a sketch. We do get the general shape. We know where it changes from positive to negative, which tells us some things. We know, the end behavior and some other stuff. We just don't know exactly how high and low it goes. Exactly. Yes, exactly. It could be decreasing until -12 and then start increasing because I don't know for sure. But I would know at least that it's decreasing between here and here. It would have to be. Does that make sense? Okay. Anything else? Good question. All right, so let's look at the next one. So here, what would you say the degree is? 4, so quartic, yes. So we have 1, 2, 3, 4. So this is 4, and it makes it a quartic. So it's a quartic, and it has a positive leading coefficient, so my end behavior is what? Up, up. Good, just like a quadratic. How many x-intercepts am I going to have? 3. What's the first one I get? 0, 0. Good. And then the next one is 2, 0, and then 6, 0. So just because it's a quartic doesn't mean I get 4 intercepts, okay? And then my y-intercept is what? 0, 0, right? If you have 0, 0 as an x-intercept, then that's your y-intercept because you only get 1 anyway, so it's 0, 0. It wouldn't give me 2 what? No, because another way to write this is I can write this as y equals x times x minus 2 times x minus 2 times x minus 6. So I get 2, 0, and 2, 0. It's the same point. Okay, does that make sense? Okay. So that's why it just shows up as 1. Just like if you were going to write it in set notation, you only write it once, even if it shows up more than once. All right, so now we are going out to 6. So we're going to make sure we do hash marks that'll fit. 1, 2, 3, 4, 5, 6. 2, 3, 4, 4, 5, 6. All right, so then my ordered pairs here, I've got 0, 0, I've got 2, 0, and I have 6, 0. But tell me something about 2, 0. Is it special in some way? We have an exponent, we have a factor that has an exponent greater than 1, right? So if I have a factor that shows up twice or 3 times or whatever, but that x minus 2 is squared, look back on the front. If it's an even one, what does that tell me it happens? It's going to bounce. Okay, if it's even, it's going to bounce. So I'm going to mark it so I make sure I don't do it wrong. This right here is going to be my bounce. It's not a minimum. It's an x-intercept that has it's one of my factors that has an exponent greater than 1. Okay, so if you have a factor that has an exponent greater than 1, then things are going to happen there. All right, so let's look at this graph. I know what my end behavior looks like, and I'm supposed to bounce it too. So I know I'm going to start up, right? I'm going to come down through here, and then I'm going to have to come back up to hit the 2. Well, that's where my bounce is, so it's going to bounce like this, come back down, come back up. And so my end behavior is up, up. I only crossed through the x-axis at intercepts. I bounced at 2 like I was supposed to. What questions do you have? Okay, so it referred to this like if you had an even power that this would create a relative maximum or minimum on the axis, which it did. So we do know where one of our relative maximums is. And I called it a bounce, but how else could you tell me that this graph is related to the x-axis, since it just touches at that one point? What if I had this? How is that line related to that circle? It's tangent. It's tangent. So this right here, this curve is tangent to the x-axis at that point. Okay, so we need to know the real words too. Like bounce is okay right now. It is a relative maximum or minimum. In this case, it's a maximum, but it's tangent to the axis. Okay, because we're going to look at that with some other zeros and stuff as well. All right, what questions do you have? All right, let's look at number 3. I want you to fill in the blanks for number 3. Don't get to the graph yet. We'll make sure we all agree on the blanks first. Do y'all agree with everything I have so far? Yes. And then your y-intercept is not 12. Is it 108? Is it a negative 108? Nobody tricked you. This gives you a negative 27, and then there's a negative out here, so it's going to give you 27 times 4. 27 times 2 is 54. Double that, you get 108, and it is a positive 108. Okay, so make sure you're paying attention to the factors that have those exponents on them, and you take that into account when you're doing your y-intercept as well. Okay, everybody good so far? All right, so tell me about the point 30. What's happening here? It has a wiggle. This is an odd exponent. So this right here has a wiggle, which is also a point of inflection. Yes? Okay. So we're going to go out to 4. We'll go 1, 2, 3, 4. You can put a fifth one if it fits. 1, 2, 3, 4. My y-intercept is up here at 108. You do have to label the y-intercept because otherwise you don't know what it is since there's no scale there. Okay, so I'm going to go to 3, 0. I'm going to go to negative 4, 0. I'm going to go to negative 1, 0. And I have a y-intercept here. Okay. Now, when you have a point of inflection, for me personally, if I just like draw the curve in there like we did before, I struggle with that point of inflection right there. Like my curve just doesn't look like it should be. So if I can, I kind of draw that little piece in first. This is what I mean by that. I know that since this is where my point of inflection is going to go, right? And there's the end behavior is down over here. It's going to have to come down like this. So I would go ahead and draw the point of inflection in like that. That way my curve, I'm not stressing out over it when I'm trying to connect it to everything else. Okay, you don't necessarily have to. That just helps me do that. All right, and I don't have any bounces anywhere. So basically I've already taken care of my special part there. And then I can start up here. I go down through this point, I go back up, I hit that 108, and then I can connect it to my point of inflection, and there's my graph. Well, thank you, Michael. That means a lot coming from you. Probably was. Okay, questions? All right, so I want you to do all of number 4. Fill in all the blanks, try and get the graph done. But you just said how smart you were. Don't tell him things like that. Make him think for himself. Oh, he asked nicely. So that's what happens when you ask nicely. Okay. Do you agree with everything I have so far? That you're going to have a wiggle or a point of inflection at -3 and a bounce at 3. So when I draw this in, since my point of inflection is right here, and I know it's supposed to be coming down, then I would go ahead and get that in there myself. And even on the bounce, if you know you're supposed to bounce here and end up back up there, but you could go ahead and put that there so you don't mess yourself up, but that's, that's just totally up to you. So then I get here, that means I'm going to come up through 243, hit that, bounce up. So double check your in behavior. I said I have it down up. That's what I said it was supposed to be. I actually hit my intercepts. I'm not crossing through the x-axis on any extra points at all, and I'm good. All right? And yours may not always look exactly like mine. Okay, and that's okay. Yours may not look exactly like your neighbors because these are sketches. The important parts should be taken care of, though. Not every single one of the ones that I gave you are fully factored. You may have to factor some of them a little bit or a lot, so make sure you're paying attention to that. What questions do you have? Because the exponent is odd, and so the exponent is odd on this one, and it's even on this one. Okay, what else you got? Anything? Alrighty, then you got lots of time to work, so make good use of it. Ugh.